Hello friends, welcome to 2 minutes concept class of physics. In the last lecture we studied circular motion. In this video we will study some important terms and formulae related to circular motion. Let us consider a particle performing circular motion. The circumference of the circle is given by c is equal to 2 pi r, where r is the radius of the circle. The period for one rotation, that is capital T, is defined as the time taken by the particle performing uniform circular motion to complete one revolution is called as periodic time or capital T. The angular rate of rotation, which is called as angular velocity, is defined as the time rate of change of angular displacement, which is equal to theta. The relation between the period capital T and the angular velocity omega is given by omega is equal to 2 pi upon T. But capital T is equal to 1 by F, that is frequency of revolution, which is defined as the number of revolutions performed by particle performing uniform circular motion in unit time. So the formula becomes omega is equal to 2 pi f, which is equal to d theta upon dt. The unit of omega, that is angular velocity, is radians per second. 1 radian is the angle subtended by an arc of length equal to radius of the circle. So theta in radians becomes arc length upon radius. Arc length is s and radius is r. So theta will be equal to s upon r. So is will be equal to r into theta. The speed of the object is related with the distance and time by the formula v is equal to 2 pi r upon t, which is equal to r into omega. The relation between linear velocity and angular velocity is given by this formula v is equal to r into omega. The angular acceleration of the particle, which is defined as the time rate of change of angular velocity, is given by alpha, which is equal to d by dt of omega. If the motion is uniform circular motion, then the speed becomes constant. The time rate of change of constant quantity becomes 0. So, the angular acceleration in case of uniform circular motion becomes 0. The acceleration is also given by alpha is equal to v square by r, which is equal to omega square into r. This acceleration is directed towards the center of the circle, which is called as centripetal acceleration. Let us see this example. As you can see, the force and the acceleration, these are directed towards the center of the circle, and the velocity of the particle is perpendicular to the direction or motion of the particle. So in the next lecture we will study rotational motion. Till then, goodbye friends.